The machines and techniques we covered in Wood 1 are great for using pre-manufactured wood products, right? So your average 2x4 or sheet of plywood from the big box store, these have already been milled. What that means is that a tree was cut down, it was cut into rough planks, it was dried in a kiln, and then it was machined down to a precise dimension. We call this a 2x4. You can generally bank on it having two parallel sides and then two more parallel sides, and they're all 90 degrees to one another. Now, with big box lumber, it's not always going to be perfect. You're going to get your twisted ones, your bent ones, your bowed ones, your cupped ones, and it's not always going to be perfectly square. You'll also notice that even though we call it a 2x4, this is 1.5 by 3.5 inches. So that's the difference between a nominal dimension and a real dimension. This is nominally a 2x4. It starts off as a 2x4 before it goes in the kiln and shrinks, and then is machined down to this finished dimension. As you advance in woodworking skills, you will move on to milling your own lumber. This is a piece of raw lumber from a sawmill. This is poplar. As you can see, in contrast to our store-bought 2x4, the surface is very rough. The sides look roughly parallel to one another, but not exactly. And the board itself has all these saw blade marks on it. These vertical stripes are from when this went through a great big milling machine to cut it into this plank. When you're buying wood from a sawmill, and there's several in Baltimore that we have a list in the back of the member handbook and in the back of the woodshop safety manual if you would like to buy unmilled lumber. You're going to be buying it in a unit called a board foot. This is a unit of measure used in the US and Canada to talk about the volume of wood. A board foot is a piece of wood that is 1 foot long, 1 foot wide, and 1 inch thick. Now, as you communicate with the sawmill, they're going to say, we have a bunch of planks at 5/4 thick, for instance, and then they'll cut it to width that you like. 5/4 means it's 1.25 inches thick, and then you're gonna have to do the math to figure out how many board feet you need at what finished dimension for whatever project you're trying to accomplish. Other sawmills will also sometimes have pre-manufactured widths, and they'll just sell you by the board, the linear foot, and then you just tell them the length of the board that you want. Board foot can get a little complicated, and it's easy to get sideways. Usually the folks you're purchasing lumber from will help walk you through the process. The next thing you got to examine is what is wrong with this board. So, when we talk about flaws in the board that run across the short dimension, it's called a cup. So you want to lay it on a guaranteed flat surface. In our shop, that's the outfeed of the table saw. Now, the board feels flat and stable here, it doesn't rock. Flip it over, it rocks. Now, just looking at it, that cup is not very dramatic. So if you can't discern it by eye, the table check helps. Next, you want to check the narrow edge. This side seems fairly flat, but we still have a little rock. This side doesn't rock, but if you get down on the level of the table and look, it's touching at each end, and then you could fit maybe a credit card under the middle of the board. So we've got what's called a bow in the board. We've also got a crown in the board. So we've got to take the bow and the crown out to make this a flat, workable board that can be turned into a useful project. This is accomplished with two tools, the jointer and the planer. We're going to start over at the jointer. The jointer works just like a hand plane might. You have two flat surfaces that are offset one another by a tiny fraction with a blade in between those two surfaces. In a hand plane, that's a stationary fixed blade. In a jointer, it's a cutter head. If you look here, we've got all these little replaceable blades, and they are affixed to a big drum which spins very fast. The outfeed table is set 1/32 of an inch above the infeed table. So as you push your material across, you are shaving a very thin layer off of each board. And as you do that progressively, it's going to knock down the high spots until you have a perfectly flat surface. Just like all the other machines in the wood shop, the blades are turning towards you and you are working in opposition to the blade. The only other thing you need to adjust on this machine is the fence. Under no circumstances should you attempt to adjust the outfeed table. These machines are very sensitive and take a lot of work to calibrate correctly. Now the fence, you want to expose just the amount of cutter head that you need to machine your board and no more. Right now it's set to its maximum extent, which is 10 inches. We're going to take a little off of it. So first you loosen this cam lock and then you turn this handle. You can hold your board up for reference. Keep going. You just want to leave maybe about 1/4 inch of the table exposed on the free edge. Then you're going to lock that cam back down. The second thing to know about the joiner is that it is located the furthest away from the dust collection machine. So it has a booster pump for the dust collection. This is very important in the joiner because you're going to generate more sawdust and chips than with any other machine in here. So you got to turn this on as well as the central dust collection. So that the video comes through clearly, we're not turning on the dust collection right now, so you will see some chips and sawdust flying up in the air as I work. For safety, you definitely want a hearing protection. This is a very loud machine. And then there are two types of push sticks for the jointer. For your leading hand, you got this flat one with a rubber grip pad on it. You're going to want to set that up at kind of a 30 or 45 degree angle to the fence. And then this is a lot like the table saw push stick. It's just bigger and beefier. And it's going to want to hook on the back of your board. You want to set your body like this, just like with the table saw. You want to be clear of kickback. Under no circumstances do you ever want to push through a board with your bare hands. That cutter head is extremely dangerous and can suck your hand right into it. So you always want to have something besides the workpiece between you and the blade. And then you're just going to push the material through. You're trying to keep the majority of the pressure down into the table on the back side of the blade before it's cut. That ensures that what is going through the cutter head is just the high spots. Just like with the table saw, you're going to kind of split your pressure between down into the table and into the fence. So getting into the fence is a little less important with this machine. You just need enough pressure that it's not wobbling around. You really want to make sure you're pushing down on the board. You always want to machine cup side down. So you want your board looking like a rainbow, not a smile. That means it's stable. If you push it through with in the smile orientation, you're going to end up with a wedge-shaped cross-section of a board. Because you'll push it flat, this side of the board will be up in the air and won't catch the cutter head. You'll run it through a couple times, and then you will have shaved a whole bunch off the fence side of the board and nothing off the free end of the board, and it will be wedged in cross section and it will be ruined. Start with cup side down. The second thing is you always joint the face first, meaning the broad side, and the edge second. And then we're going to have two faces of the board that we know are flat and perfectly perpendicular to one another. And then we can take it on the table saw, put those two machined surfaces against the fence and the table there, and create a third parallel flat surface. And then we'll take it over the planer and create a fourth parallel flat surface. So I'm going to make a couple passes through, and I'll hold up the board right after so you can see kind of how much is getting shaved off each time. And then once we get a flat face, I'll flip it up on the edge. So as you can see, in that first pass where it's smooth, those are the high spots that have been knocked down. And this rough part of the cup still needs to come off. I estimate it'll probably take 6 or 7 passes before it's perfectly flat. When you're buying rough sawn lumber, you've got to take that into account. If you're looking for a finished dimension of 1 inch, you probably want to order a material that's at least 1.25 inches, but probably 1.5 inches thick to give you enough surface to machine down. Third thing is you should always leave the machine running. This machine runs on 3-phase power. It has a really powerful motor in there, and turning it on and off a lot suddenly is a great way to burn it out. It actually runs way more efficiently once it's spun up, and since the cutter head is covered by this guard, when it's spinning, it's fairly safe to keep it running. Just be aware that it's running and don't get near the cutter head as you reset for your next pass. Now you can see we have a perfectly flat and smooth face. If you lay it on a flat surface, there's no rock whatsoever. You can look under it and see that there's no daylight whatsoever. The cup has been completely eliminated. Now it's time to turn it on its edge and make sure we have a parallel edge to the main face. Same as before, you want the rainbow effect, not the smile effect. So you need to check your board, make sure you have the board where just the two ends are touching. If you do the one where it's a smile, you're gonna rock over the cutter head and again end up with either a curved or wedge-shaped board. Second thing is you need to move the fence so you're only exposing this much of the cutter head instead of the amount that you needed for the face of the board. Now for edge jointing, you're going to want to kind of reverse the proportion of force. If before you were maybe 70% pushing down into the table and 30% pushing against the fence and forward, This time you're going to want to go 70% into the fence because that's your flat side, your accurate side that you're registering to, and then only about 30% down into the table. Second, these tools aren't very useful when they're bearing on just an inch thick strip of wood. So this, since it sticks up well above the fence, is tall enough to safely hold with just your hands, but you still want to be very, very cognizant that your hands never dip below the top of the fence if you can avoid it. You may need to keep some pressure on the face of the board to keep it pushed into the fence. Just make sure that your hand stays well behind the red cutter guard while you're doing that. And then if you need to ride over a little bit, keep it as high as possible. So I'm going to show you how to edge joint, and then we'll get started with the planer. Now we have jointed the face and the edge of this piece. These two faces should be at a perfect 90-degree angle. As they say, trust but verify. We have a wide selection of squares on the wall of hand tools by the dust collector closet and the entrance. So you can double check that it's square as you'd like it to be. Now we're going to run this through the table saw to take this edge off. And the important thing is, you want to run the machined edges against the fence and the table. You see how we're gradually making the board more and more accurate. And what that means is each face that you machine needs to then ride against the sides of the machine. So we'll go ahead and just adjust the saw as we learned in Wood 1. Take the blade up. So just the gullet is barely exposed. We'll set the fence to just shave the edge off, making sure the wide part of the board is between the blade and the fence. We'll tighten the fence down. We'll make sure that we have a push stick handy, even though it's a big wide board. We'll let the blade come up to speed, and then we'll push it steadily through. Now our board should have 3 machine sides. The 2 narrow edges should be perpendicular to the face. The last thing to do is to clean up this top side. And for that, we're going to use the planer. The planer is the only machine in the shop that really does the work for you. When you have it calibrated correctly, you really shouldn't have to push the material through but a tiny bit before the cutter heads grab it and propel it through on its own. However, it's a very sensitive machine. If you make it a little too tight for your piece of wood, it's going to bind up and the wood will get stuck in there. I'll show you what to do in case that happens. But the first thing to do is to make sure that you set the depth as precisely as possible. What that means in this case is to hold the board against a flat surface. If you look really closely, now that we've machined one flat side, even though the board is cupped, it means it's thicker in the middle than it is at the edges. So you're gonna wanna take a couple spot measurements. We got 1 inch and a 1/16 at one end. And we got 1 inch and a scotch under a 1/16 at the other end. And we have 1 inch and a little more than a 1/16 in the middle. So you're gonna wanna set the planer to your maximum dimension of the board. Come over here. This holds the bed. Loosen that. And then adjust to 1 inch and a 1/16. There's inches on the left side of the scale and metric on the right side of the scale. Now, this may mean that the planer doesn't really cut the first pass, but that's important to get you to calibrate the depth correctly. If I set it at 1 inch, say, the board would likely get stuck in the middle while it was running. If that happens, you go ahead and turn the machine off, undo this, and just lower the blade and back your board out. There's barbs, there's actually rotating teeth here that catch the board and prevent it from ever going backwards. So if the board gets stuck, the only way out is through, right? So you have to actually back the board down. The other thing to know is that when the cutter head first grabs the board, it may lift the board up slightly, especially if it's long. The board has a tendency to act like a lever, and as the pressure of the cutting head goes down on one end, it'll go like that a little bit. And it'll leave what's called snipe, which is a little shallow, slightly deeper cut at the beginning of the board where the planer grabbed it, and the same thing might happen on the back end. If you're looking to make something really precise, you need to leave a little extra at the front and the back of your board that's sacrificial that you can cut off later because it's going to get marked up with that snipe as you run it through the planer a bunch of times. Next, you're going to make sure the stop is pulled out, start the machine, and pass the board through. Again, the machine will grab the board and kind of self-propel it, pull it out, and then you're going to raise the bed by a 1/4 turn of this wheel, tighten everything down again, and run it, and keep doing that until the board is smooth. Just like with the jointer, this has one of the most powerful motors of any of the machines in the shop. You don't want to be turning it on and off a whole bunch, it'll burn it out. Just leave it running in between passes. As you can see, the planer is going to generate a whole lot of chips and dust. You're going to want to make sure the blast gate is open and the dust collection is on. But even when this is operating at full capacity, you may get backup. At the end of using the planer, lower the bed down . As far as you need to get in there with one of the orange shop vacs and make sure that there's not a lot of junk caught up in the dust outlet. Routers are an incredibly powerful and versatile tool in the wood shop. They come in both handheld versions and stationary versions. We're mostly going to go over the router table, but to illustrate how routers work, I'm going to show some handheld routers which we have available in the gray cabinets behind the dust collection closet. This is a large handheld router. You're going to hold it with two hands and move it along the workpiece. The bit spins clockwise. It goes in here in what is called a collet. It's very similar to the chuck on the drill press. This smaller router, often called a palm router, is for finer work that's closer in. Many people, after a lot of practice, can use this freehand. These machines work with cutting bits as opposed to drilling bits. Here are some examples of router bits, and what you have to imagine is that the positive shape of the bit is the negative shape that will be left on your workpiece. So there's a great variety of bits. This is just a small variety. This case does a good job of illustrating kind of what the finished cuts look like. So a wedge-shaped cutter, we'll put a 45-degree chamfer, and you have some roundover bits that will make a nice clean roundover. And then you have fancier bits that can put complex profiles like you might find on molding. This allows you to put finished edges on projects. Using just a straight bit like this will allow you to make very precise dados, rabbets, and channels and pieces of wood that you can use for joinery, for making finger joints, for making drawers, and other fine cabinet making applications. While this tool is very versatile, it is also pretty dangerous. It is in a non-stationary application. The router can move all around, and it has a spinning bit attached to it, which can be very dangerous if it skips out of your cut. To prevent that, most of the router bits that we have some sort of bearing on them. What this bearing does when you're running down the edge of a piece of wood is it provides a smooth guide, right? So depending on the depth of the router, you can set how much you're cutting off, and it will never cut off more than that because the roller bearing will prevent the router bit from cutting into the material further horizontally. So once you lock the vertical dimension, all these are adjustable in the vertical dimension. The horizontal dimension is taken care of by your router guide. In general, just like every other machine, you want to move against the rotation of the bit. On the router table, that means right to left. And I'll show you how that works. So the router table takes a handheld router, flips it upside down, and secures it in a table with a fence and some other fixtures that allow you to do more complex milling operations. This fence is unique compared to the fences on other machines in this shop in that it can be adjusted at an angle. It has two fixed points at each end, and it can rotate basically in any orientation. So if you're trying to do a straight operation, you need to put a square against it and check at both ends to make sure that it is parallel. Second thing we're going to show is mounting the bit in the machine. Make sure that the machine is off and unplugged. Below the machine we have drawers with the throat plates and all the necessary wrenches and tools. Unplug as an extra measure of safety. The throat plate twists out, so you're going to want to turn clockwise and it'll come out. And then the collet, it's a little hard to see, but it has two nuts. One is the actual spindle of the machine, and one is the nut that secures the collet. So you're going to come in below here. Now, when you're loosening the collet, you're pulling the wrenches away from one another. When you're tightening the collet, you're pulling the wrenches towards one another. The one in my left hand, which is on the spindle, is really mostly just holding the spindle stationary, and the right one is loosening the nut. Usually you only need to do 1 or 2 loosens with the wrench before it's loose enough to turn by hand. It can give way a little suddenly, so just be prepared. You can take this out. You'll notice that this has a 1/4 inch shank. We also have bits with a 1/2 inch shank. To put in a 1/2 inch bit, you have to change out the collet insert, which is this little piece. This will, if you unscrew this nut all the way, this will come out, and you can find the 1/2 inch inserts in the drawer below the machine. When you put the bit in, you're going to want to seat it all the way down, so the maximum part of the shaft, or the maximum amount of the shaft of the bit is held securely in the collet. You don't want to have it sticking out like that and only a little bit securing it in the collet. This thing's moving at an incredibly high RPM, higher than any other machine in the shop, and if you don't secure the bit, it'll fly right out. Hand tighten the nut back down as much as you can, and then go back in and finish tightening it down. Once you physically cannot tighten it anymore, it should be tight enough. Just give it a little hand check. Pop the throat plate back in, turn it counterclockwise to lock it. Now you're going to want to return the fence to the position that you'd like. See how it can move at different angles? Well, I want mine to be parallel. You want the fence to be right over the center point of the bit. Tighten down one side first and get your square. Bring the second side square and tighten it down. Now with the router table, it's generally advisable to run some test cuts before you commit to your final piece. It can be a little finicky to dial in the height of the router bit and the position of the fence to exactly where you want it. So we've talked about adjusting the fence this way to support your workpiece. To adjust the height of the router bit, there is an Allen key in the center marked with some measurements. It's right in line with the bit. The Allen key is kept in the drawer below the machine, and you rotate counterclockwise to lower the bit and clockwise to raise the bit. Generally what you're going to want on a bit like this, see the little ridge around? That's what you're going to want to be level with the table. In certain circumstances, you may want this part of the cutter head exposed, but usually when you're using a cove bit, you're just trying to, a roundover bit, you're just trying to take off the corner of the material. But again, since it's a lot harder to calibrate than some of the other machines we've looked at, use a piece of scrap to kind of dial in your settings before you commit to your finished workpiece. In the handheld router, the bit spins clockwise. However, to mount the handheld router into the router table, mind you, we flipped it upside down. That means the bit is now spinning counterclockwise, which means that the feed direction is generally right to left. So we're going to just double check our fence one more time, and then we're going to run the material through. Looking good. Again, we have a two-part safety switch. We've got the big paddle switch for shutting off. Since this bit has a bearing at the top, we didn't really need the fence. The board just ran against the bearing the whole time. The fence becomes more important when you're using a bit without a bearing. As you can see, it left a nice clean round over. If it was not calibrated correctly, if the blade was, if the bit was too low or too high, you would see a ridge right here, and the cut would look more like that. But as you can see, we don't have any ridge, and we just have a nice clean edge. So if that's what you were going for, you'd be free to run the rest of your boards through and move on. Last thing to note is this is not hooked up to our central dust collection system because it's a tool that is not used as often. The back of the fence has a dust port which interacts with a standard shop vac. We keep a shop vac in the corner here by the drill press and the router table, so you can just pop the hose off, put it in here, and just run that as standalone dust collection when using the router table. Dust is a major hazard in the wood shop. It's slippery, it's flammable, and it's an inhalation hazard. We do everything we can to keep dust to an absolute minimum in this shop. The first line of defense is the centralized dust collection. Please make sure it is on and the blast gates are open whenever you're using any bench tool in the shop. Second, wear a mask for personal protection. Third, we have hanging air filters, one at each end of the room, which can be turned on during periods of heavy use. But last and most importantly, clean as you go. When you're finishing operation at one machine, please clean up all the stray dust. Sweep first for all the big chips, and then use one of the orange Rigid brand shop vacs to clean up any other surface. The yellow DeWalt brand shop vacs are special machines. They are HEPA filtration machines, and they have a special end which plugs in to our orbital sanders. These are only to be used for that purpose. Please do not use the HEPA vacuums for just cleaning up the workbench. It's really bad for them and can burn up their motors. Thank you so much for taking the time out of your day to watch this video. We look forward to learning alongside you as you pursue your own projects right here at OpenWorks. We're located at 1400 Greenmount Avenue, Baltimore, Maryland, 21202. You can find out more information about educational programs, membership, small business development, and grant-funded programs at openworksbmore.org or on Instagram, Facebook, and Twitter at openworksbmore. So whenever you're machining wood, you're going to be fighting tear out, which is when the grain kind of rips and shreds away from the backside of your cut in an unsightly way that can be a little hard to sand out later. To prevent tear out on the jointer in particular, when you're running the broad face of the board through, that's going to generate a huge amount of friction. You got the maximum amount of surface area going against the blade. Now, over here I've highlighted the grain lines with a pen so they're easier to see. Whenever possible, you want to joint downhill. In other words, the grain lines should be pointing down towards you. See how these kind of trend into the table? If you turn it around this way, you're going in opposition. The blade is going in opposition to the grain, and you're going to end up with a lot gnarlier surface. However, it can be really hard to tell which direction the grain is running, especially when the material is rough sawn and you can't clearly see an edge. What you can do in that case is just cut off a little sacrificial piece with the chop saw, or carve a little bit away with your penknife to see which way the grain is trending and orient your piece correctly.